Back again with another Cast, and we're going to start right off by doing a problem on projectiles. Here is a problem where a ball is kicked at 40 degrees off the horizontal, and this time we're looking for how high the ball goes. Let's pretend that this problem was being videotaped and we did video analysis, and the camera wasn't able to capture its height. It wasn't able to figure out how high the ball actually went. But we did get some information about its horizontal position. We did figure out that the ball actually travels in the x direction 34 meters, and that using video analysis we were able to see that it took 2 seconds to go that 34 meters. Knowing that, we can figure out how fast it's going. If you take 34 meters and divide it by 2.6 seconds, you get 13.1 meters per second. That turns out to be the object's x velocity, the velocity in the x direction. So if we look at the blown up version of the velocity of a ball kicked at 40 degrees, the x component of the velocity would be 13.1 meters per second. And we need to figure out the next step, which is figuring out the v sub y, the y component of the velocity. Now that can be done by taking tangent of 40 degrees, which is equal to the y component of the velocity, divided by 13.1 meters per second. Now the reason we use this is tangent of an angle is opposite over the hypotenuse, or opposite over the adjacent side. So this is the opposite side of the angle, and this is the adjacent side. If you solve and figure out what that answer is, it turns out that the y velocity, the velocity in the y, is 11 meters per second. So that is a helpful piece of information, because now we need to shift to figuring out how high it went, and we need to use the big equation y final equals 1/2 g delta t squared plus the initial velocity times delta t plus its initial position. And so the first thing to remember here is that this is a y equation. This is an equation that's dealing with all motion in the y. So you see right here v sub I. A very common mistake that students make on a quiz is they will put maybe the velocity that's the hypotenuse of the triangle, or in this case they might have found out the 13.1 meters per second, which is the x velocity, and put it in that spot. That is not correct. This velocity can only be the velocity that's in the y, because this equation has g, which is in the y. So what needs to go there? You need to put 11 meters per second there. And then the next thing that we fill in is the amount of time. And you can see that the amount of time is 1.3 seconds. And you may be asking yourself, well, where does the 1.3 seconds come from? Well, that's just simple. If you go back up to the problem and you look at the ball, it's kicked and it goes all the way to its highest point and then comes all the way back down. That takes 2.6 seconds. So at its highest point would be half that time. So that's where 1.3 comes from. Now, the initial position is the ball, the y initial is where the ball was kicked from, that's 0 meters, and where is it going to be after 1.3 seconds is what y final will be. That's also our height. So as soon as we solve that value, we know how high it is. And it turns out that that height is 6 meters. Now this is a typical projectile problem. We've done others in class where I gave you the initial velocity at the angle and you had to figure out how far it goes. I could do this problem a different way. I could give you the height and you could figure out how far it went. All the problems are the same, really. It's just that you have to find the missing piece. In this case, the missing piece was height. Usually you have to find time, or you have to find one of the pieces of velocity also as part of the story. But for the most part, all these problems are the same and they follow a similar format. You start with a velocity, you always need the components, you need to find the time, and you just use these two equations. This is probably the most important equation right here, the y final. And that's it. That's a typical projectile problem. Enjoy!